When shuttles return from space, the normal scheme for landing is usually a vertical high-speed drop into any of Earth's oceans. For example, the Apollo 11 of 1969, man's first shuttle to touch the moon, landed in the Pacific Ocean. Even the newest space capsules, the Dragon and Starliner, both land in oceans. Sierra Space, in cooperation with NASA, takes this up a notch by creating the Dream Chaser, a spacecraft that could land horizontally like an airplane. And yes, it could land on any runway around the world, you name it. Now, Sierra Space's Dream Chaser hasn't yet been tested on crewed missions or cargo missions, but it looks promising as the world's next vehicle for space tourism. This, however, seemingly mocks Elon Musk's SpaceX shuttles, and so Elon decided to bring a fictional event into reality. Basically, we might be looking at a future where rockets don't actually land in water or on runways. We are talking about a future where these spacecraft would quite literally be caught mid-air. That seems impossible, right? This video will change your mind. Just watch till the end. Welcome to the SpaceMinds channel. Here we love rockets and space, and we know you love them too. So why don't you let us take you on amazing adventures of the unknown and unveil the hidden secrets about space? You definitely don't want to miss out on any of our space adventures. So hit that subscribe button and turn on the notification bell, and we will update you on all our newest stories. While a splashdown, as it's called, seems almost totally harmless, it actually is a really risky form of landing. Here's why. Even though the water is meant to cushion the vehicle on landing, the impact force can be so great it could shatter a hole through the craft. If this was an emergency landing, well, the astronauts might suffer traumatic brain damage and several fractures. There's also the risk of hitting an underwater hard surface. This could potentially kill anyone inside the shuttle. If the impact is large enough, the spaceship's hull might become compromised and accidentally allow water into the ship. If an astronaut isn't an expert swimmer, he could die from drowning. How about the fact that this can cause an electric fire that could cause the shuttle to explode? Guess you never considered that. Even though the water might cool the vehicle just a bit, there's the potential of overheating from the burn following the spaceship on entry. This could make the interior of the spacecraft extremely hot, increasing the risk of dehydration if a recovery team doesn't arrive quickly. There's also the tendency for chemical contamination of water in case of gas leaks on impact. If there's a gas leak, the crew might get doused in it too. We don't even know how the sharks and whales will react to us barging into their home, quite literally. I guess these are enough reasons as to why space travel institutes like SpaceX are pushing for anti-splash landing. So what did Sierra Space do about this? Sierra Space's Dream Chaser is one of the newest space vehicles known to mankind, created to completely solve the problems of splashdowns. The shuttle is quite literally a spaceplane, having wings that span up to 30 feet. Like the Starliner and Dragon, it is reusable and was created for up to 15 flights before requiring major repairs. The Dream Chaser is also thermally protected with heavyweight silica material, enough to insulate the spacecraft from external heat. Dream Chaser is also planned to be fully automatic, like the Starliner and Dragon. However, what really stands out about the Dream Chaser is its landing system. It is equipped with retractable landing gear that allows it to deploy a set of wheels in exactly the same way a commercial airplane would land. This cancels out the tendencies of certain negative events of splashdown, including chemical contamination of water, the possibility of electrical glitches due to water, and the risk of traumatic injuries on impact. Even though the Dream Chaser's horizontal landing affords us a bit of comfort, there's also one problem it could bring up. Like we have plane crashes, we could also have a shuttle crash. Technically, I believe it could be more dangerous than a splashdown impact. Yeah, even something this good comes with its own dangers. Considering all these dangers, Elon Musk decided to do something NASA would call impossible. In science class, you definitely would have seen what a clamp stand looks like. If you don't know what it looks like, it's more like a long vertical pole with two horizontal arms used to hold a test tube in place. Now imagine this. A huge clamp stands several hundred feet high with large horizontal mechanical arms. Only this time, not test tubes, it's for rockets. Yes, Elon Musk plans on having these giant clamp-like pillars to catch and support one of his newest set of boosters, the Super Heavy. The Mechazilla, like the Godzilla, is technically an idea far from the ordinary. Its immense size is one thing to consider, its function is an entirely different thing. Let's talk about the Super Heavy. So normally we've got thrusters that just launch shuttles into space and then become useless, either just floating around as space trash or returning back to Earth as pieces of metal. What if we had a set of thrusters that could easily launch a spacecraft into space and then come back down to Earth wholly for another launch? Reusable thrusters, yes. And while the current landing mechanism requires the Super Heavy being caught by the Mechazilla mid-air, it also has backup landing legs for landing in oceans or on land. The Super Heavy boosters are designed to provide enough power for the Starship launch system, SpaceX's next shuttle, and to also return back to Earth for a new launch. We're looking at a future where we launch numerous spaceships with just one thruster. Don't get too shocked yet. Wait until you hear about how these boosters are to be received on getting back to Earth. NASA couldn't believe their ears when Elon explained to the world how he intends to use the Mechazilla to catch the Super Heavy boosters mid-air. Currently, there are already some Mechazilla models used for launching SpaceX's spaceships into space, and the booster catching program for them has been enabled. Tests have also turned out favorable. Anyway, Elon explained that while the Super Heavy boosters would come with high speed, a smaller propulsion system with Raptor engines would become operational as the thrusters enter Earth. These would slow down the Super Heavy and also bring it to the Mechazilla tower. Then an alignment system would come online to place the thruster in line with the Mechazilla, whose automated claws would move to hold the Super Heavy in place. All through these, the booster is still mid-air. This insane idea would revolutionize the world of space travel, making both reusable spacecraft and reusable space boosters. That way, we don't litter space with our metallic debris, and we also don't waste so much on making new thrusters. A problem with this landing, however, would arise from precision and timing errors. If the Super Heavy isn't able to properly align with the claws of the Mechazilla, the catch might turn out impossible. This has a great tendency of happening because the alignment sequence would need an almost perfect precision, and the timing sequences of the Super Heavy and the Mechazilla must be the same. If not, we could see the claws deployed too early in the catch or the booster aligning too late. With SpaceX precision records, I feel this shouldn't be an issue for them. There is also the potential for misses with the catch. If the rocket is even a tiny bit off target, or if there's a failure in the guidance or alignment systems, it could miss the Mechazilla claws entirely, causing a catastrophic crash. This could damage both the booster and the launch tower. That's billions worth of space equipment, a huge risk for SpaceX and also for NASA, as they'd have to cooperate for space missions. Any malfunction with the claw deployment or issues with the hydraulic systems could lead to a failed catch and a potential dangerous crash. Technically, if there is no catch, there will be a crash. There are also the dangers of impact stress on the Mechazilla tower once the catch is made. If the tower lacks structural integrity, a catch could actually turn into a crash. Overload stress, software failures, as well as viability issues should also be considered. All these possible issues with the mechanism explain why NASA still remains skeptical about Elon's big plans for his Super Heavy, despite the promising advantages of this catching system. Apparently, we can't look over the feasibility of these problems with the mechanism. Even at that, Elon Musk stopped at nothing to achieve it, and now we already have Mechazilla towers that are able to catch the super heavy boosters. Sooner or later, we might see landing towers for receiving spaceships themselves. Believe it or not, SpaceX might be on this already. Who knows? While the Mechazilla and Super Heavy boosters both have great promises for the future of space travel, they do have particular setbacks to them, which SpaceX would really need to analyze critically. With a history of great efficiency and much less failures and explosions, I think SpaceX are onto something with the catching maneuver for their boosters. Like Neil Armstrong said on landing on the moon, one small step for man, one giant step for mankind. With that, we reach the end of this video. If you've enjoyed watching, hit the like button, share it with your friends, and subscribe to SpaceMinds for the latest updates on our space news and adventures.